Hey, what's up everyone? Glove here, and in this video we're going to be talking about functions in Go. So let's get started with what a basic function looks like, right? So we have this code here, and I want to draw your attention to this bit right here, where we have a very basic definition of a function, or actually it's a declaration and a definition of a function, right? So we, much like in other languages, right, we have a keyword. In Go's case it's func. And then we have the name. It can take in some arguments. In this case, we're not taking in any. And then we have a return value right here, which is just going to be a number. And in our case, what we're doing is we are just getting a random number based on the time that it is right now. And then we're just going to return that number, right? And so if we run this code, we will see, go run. We'll see that it prints out 87, right? And that's from this print statement right here. So nothing crazy going on, super, simple, right? Let's say that we have some kind of object, right? How do we write methods, as they're called, for these objects, right? And a method is just, a function that is specific to an object that defines some behavior for that object, right? So we have, let's say, a mock connection, right? And let's say that maybe this is like a connection to a database or something like that, and we have a name on it, right? And then what we can do is we have these two methods here, and we're going to use this struct, by the way, later on in this video. But what we do is we define a struct, which is the receiver of this function. So you'll sometimes hear these called receiver functions or methods, as we refer to them from other languages. And so basically we're saying that this type right here, this struct, mock connection, can connect and it can also close, right? And so that would be a pretty simple way that we can add behavior in the form of methods to an object, or to a type of object rather, right? And so actually we're going to use these methods later on. All right, so let's comment this out. And let's uncomment this out. Now let's talk about return values and multiple return values. So you might have noticed that we had a single return value, which was an integer right here, right? But in Go, we can uniquely return multiple values of the same at the same time, and they don't have to be of the same type, actually, which is also quite interesting. So how would we do that? We might, in this case, declare multiple return values using kind of just in the same way that you'd have your arguments with, commas, right? We do the same thing here, right? Multiple return values, we have another set of parens, and then we just have a comma separated list, if you will. It's not technically a list, but a comma separated, group of return values, right? And so we do that here. We return our integer or an error, right? And so what we're doing in this case is we are basically saying that if the integer that we create, by the way, this is the same code that we had before. So we're getting a number that is random between 0 and 100. And if the number is greater than integer, then, if the integer that is generated is greater than 50, then we create a new error and we return the error along with the integer. Otherwise, just return the integer with no error, right? And if I were to run this code, we'd see that we get 3. The error is nil because 3 is not greater than 50. Same thing again. Let's see if we can get 1 just to demonstrate that this does work. 57, that is in fact above 50, and that works, right? So pretty basic thus far. Now, let's do this. Let's talk about named return values. And this one is pretty interesting, okay? So right here, this is a similar syntax to what we had before. You might also write it like this, which probably looks a little bit more familiar to what we had before. But in Go, if two things are of the same type, you can just omit the first type of that first object, and on the that first argument or return type. And on the last one, you just have the type, right? And so this is saying that both of these things are going to be of type int. Now, what we can do is we can say that the first return of type int is called num1, and the second one is called num2. And so this actually initializes these two variables to their zero value. So in the case of an integer, they're initialized with the value of 0. In the case of a string, it would be empty string, so on and so forth, right? And so now what we can do, actually, if let's say we run this here, we'll see that these two things are 0, again, because the 0 value, it's called, of an integer is 0, right? And a 0 value is like the initial value of a type. But if I were to change this here and actually kind of be overriding this, what would happen? Well, we'd have 1 and 2, because even though we don't have explicitly, something like this where we're saying that there's a variable, basically what's happening is that Go is creating variables for us. And that's why when I hover over this, it says that this num1 is basically a variable of type int. And so you might hear of this called a naked return, because what happens is that when we actually go to return this, whereas here we were returning the integer and the nil, we don't have to do that. All we need to do is return nil, or just return, and automatically our named return values or variables will be returned. This therefore is called a naked return sometimes, because we're not actually saying what we're returning, it's just kind of implied, it's implicit. So something really, really important is that a named return value can be useful to provide code clarity, right? So if we are returning something very, very specific and we want to, as part of the function's definition, say what we are returning, right? So if you highlight over this or hover over this, it will give you the function definition. If we want to be explicit or convey some sort of clarity about what exactly our function is returning as part of the definition, then that's totally fine. This adds clarity, and so we should do it. However, we shouldn't just do it so that we don't have to specify what we are returning here, right? Like this, the fact that we have to do this is not a reason to use named returns, okay? Only where it adds clarity to your code should you do that. But in reality, this might be, or specifying, right, that num, I can't spell for some reason, specifying what we are returning is probably more clear, right? Even though we might not have it in the definition. And we're actually going to see in the next section, next file, we're going to see an example of a time when this is not as clear as doing it a different way. All right, so let's comment this out, and we'll do some basic defer now. All right, so in the case of a defer statement, what's happening is that we're basically provided a way via the defer keyword to basically say to Go, we want this function to run before the parent function returns. And what that means is that we have two statements right here, two functions, right? We have this two print statements, right? But we're telling Go, hey, don't do these right now. Recognize that they exist, but don't do them right now. Instead, do them here, down here, before the function actually is returned or before it actually ends its execution. And so when we run this is going to be kind of interesting as to what gets printed first, because these two things will be evaluated but yet then ignored or saved for later, and then this will execute, and then these two things will execute. So when I run this, we get 3, 2, 1. Now, interestingly enough, why do we get 3, 2, 1? Let's take a look at that right now in this next example. So we'll comment this out. We'll uncomment the defer order. And now in this example, what we're going to see is a more clear example of the order. So if I run this, right, go run, we get, we get 4, 3, 2, 1, and then 0. But this is kind of interesting because when we go through this, I starts out at 0. And so we would think maybe that this defer statement, since I was the first one in, it should be the first one out. But that's actually not the case. Defer statements are actually executed. They're evaluated in the order, of course, that you write your code. But they're executed in a last in, first out. They are basically a stack. Now let's talk about some argument evaluation for defer statements. And this is where I think they were already pretty interesting, but they start to get even more interesting on this concept. All right, so from the documentation, the arguments to the deferred function are evaluated when the defer executes, not when the call executes. Which is interesting, okay? Now what this means is that the execution of the defer keyword and the execution of the function that was being deferred are actually separate things, right? When the defer keyword is called or executed, it simply evaluates the function and then worries about actually executing that function later, of course, right? Because that function is deferred until the function, or right before the function returns, right? So what the defer function is doing then is simply adding a function to the call stack. And then this function is called sequentially in LIFO order, so last in first out order, immediately before the function returns, right? And we talked about that. So let's look at this kind of example, right, about arguments. Now, this function here, which is an anonymous function, has, and this, by the way, is how you write anonymous functions. A lot of other languages have them as well. In this case, there's simply just the func keyword followed by the arguments that it will be taking in with no name to it, hence the anonymous part. Now, we have this error here, and we're not passing in any arguments into our deferred function. Instead, what we're doing is we are just having the deferred function, which is just running a print statement, use this error variable right here inside of its parent function. Now, what this does is basically just uses whatever value it has at the time of its execution, which means that down here later on, we're actually setting a value to error. And so when this runs, there will be a value in error, which we will then see as, first defer having an error in it, right? Now let's talk about what happens when we actually, give an argument to a deferred function, and then we'll run them and we'll see what the difference is and kind of what I was trying to explain here. So this argument here, remember that these are evaluated when the defer statement or when the defer keyword is run, which is before the function is actually executed. And so the value of any of these arguments will be not what it necessarily is at the end of the function. It will be what it is at that specific point in time, which until now, the error variable has not been given a value because that comes down here at the end. So when we go to run this, what we see is that deferred function 2, which is right here, is nil, right? It has a nil value because, again, error is not actually assigned a value until later on, which this has already been evaluated. However, because our first deferred function right here is just using the error the variable that's inside of its parent function, that means that it will actually have the value that we might have expected it to in this one, right? So that's kind of like a gotcha, but it's just really, really important to know because you're going to end up doing something and it's not really going to be acting the way that you think it will be. All right, so let's talk about maybe a more common example or maybe a more real world example of when you would use defer, right? Because up until now, I've just been showing you the mechanics of how it works, but we haven't really talked about when you might use it. So let's say that we have a database connection, right? So if we go back here to this mock connection, right, we have this connection right here, and then we have these two methods on that connection called connect and close. And so, what this essentially does is it gets our connection right here. So we have our connection, and if we run this, we will see that actually nothing happened. Why didn't anything happen? Because this isn't doing anything. We will see then that we now have a connection which is connected to MongoDB. There is no MongoDB here, but as we can see inside of connect, all it does is just prints the name. And to make this a little bit more clear, we can add this. Likewise here. Okay, sorry about that. All right, and we see connected to MongoDB database. Okay, pretty easy, pretty simple. Now, What you'll need to do though is when you're done with the connection to a database or really to anything, you want to make sure that you close that connection and you don't just leave it open for no reason. This is considered bad practice and can lead to a lot of other issues with your software that we're just not going to cover right now, but it's something that you'll probably learn about at some point or another. If you're new to coding, you'll definitely learn it. If you're not new to coding, you're just new to Go, you've definitely come across this at least once before. So what we want to do is we want to make sure that we close this connection. And so typically what you might do is you might do this, where you would have, some code here. You might have a long body of code. It might be 100 lines of code inside of this, inside of this function. I don't know, whatever it is. And then at the end of it, you would close your connection off, right? Via this close. And so if we run this, it's going to say connected to database, MongoDB, and then MongoDB database closed, right? The problem with this is that you might end up needing a lot of these close statements. You might have a lot of different paths that your code can get through, not necessarily just one happy path. And so you end up basically potentially in situations where you might have forgotten to have this close statement right here to run this close method. So what the defer statement is really helpful for is that now what we can do is right after we connect, we can have defer close. And this basically ensures that no matter what our code is doing, it will always be closed at the end of the function's execution. And this is really helpful because one, it helps us write better code, but two, we can also see right afterwards, and this by the way is a convention to put this defer right after you actually open something. So now we can really see, it's much clearer because it's in one place. We can really see what is happening here. So in this way, the defer statement is a really powerful thing to make sure that any cleanup that has to happen as part of running a function is guaranteed to happen no matter which path or which, path of execution our functions take, right? And so in that way, we're able to write better code using the defer statement. So I hope you guys enjoyed this video. I appreciate you guys watching so much. Let me know down in the comments what you guys learned about in this video. That's always cool. And then also let me know what you guys want to learn about Go in the future. And hopefully I can try and make a video on it sometime soon maybe. So thanks for watching again, and I will see you all in the next video. Take care. Peace.